Have you ever wondered how the default sorting works in Python? In our last video, we compared a range of sorting algorithms, but we also included the Python default sort, which was much faster. So that has led to the question about how does this default sorting algorithm work and why is it so much quicker? Despite beating the other more well-known algorithms, Timsort doesn't seem to be understood, or people don't seem to know about it. So we thought we'd do some research, and let's have a look at what we found. So first of all, the Python default sorting algorithm is based on Timsort. Now, let's start off by saying that Timsort uses runs. So here we've got a range of numbers. Now if we want to sort them with Timsort, first of all, we split them up into parts. And these parts, sublists or subarrays, in Timsort are called runs. So you can see here the numbers are in different colours, and we have runs of size 4. Now, we can order those runs, and then we want to merge them. So here you can see there are actually 8 runs. So we can merge the first and second, third and fourth, fifth and sixth, seventh and eighth. We do that, we've now got 4 sublists, so we can merge the first and second, third and fourth. So now we have 2 halves of ordered numbers, which are quite easy to merge into the ordered list. The difference between the Timsort and a normal merge sort is it also uses insertion sort. Now insertion sort is very good if the numbers already have some order, and it's also more efficient on smaller lists. So here we can see the advantage. We can order these 2 lists of size 4 into order, and then we can use merge sort to merge them into one sorted list. So in this example, we use the benefit of insertion sort on the smaller lists, but we also use merge sort to merge them. So we've used this list before in our videos, so let's remind us what merge sort is like and what is different about Timsort. So here we have merge sort. First of all, we split our numbers till they are single sub lists, single elements, and then we start to merge them together. Now once we merge them together, so there's 2 halves, we can then put them in the ordered list, and that's quite efficient when they're long lists. Now with Timsort we can use the insertion sort to order the smaller lists. That makes it more efficient. So that's our first example of how Timsort is more efficient than the merge sort. Here we've got the merge sort, but the numbers are already in order. What happens? Well, it goes through the same stages, so that's not very efficient. Now you can see there's many operations, but do we really need to do these? Well, with Timsort we don't. Because they're already in order, we can see the 2 halves already in order, so we just need to merge the 2 halves. So that's much more efficient. What else? Well, the default sort also uses binary insertion sort. So normally insertion sort uses a linear search for each element, and that results in a lot of comparisons and shifting of the elements. If you use binary search is more efficient, so it also uses the existing order. So there's less comparisons and less shifting. So that makes it, again, more efficient. Timsort merges smaller into larger lists. So in this example we can see a range of numbers, and just for the example's sake, imagine we could split these into a longer list and a shorter list. Well, it's more efficient if you can use a binary search to just insert the smaller list element by element into the longer list. So by the fact that you're using the binary search means there's an efficient way of using Timsort to put the numbers in order, because you use the longer list and insert the shorter list elements inside that. Again, another way how Timsort is more efficient. Also, it used galloping. So what does this mean? Well, here we've got two lists. Now we can see 1, 2 and 3 will just go into the main list, but you can see as well we've actually got a list, a list B has numbers in consecutive order. So after the 1, 2 and 3 we could put the 5, 6, 7, 9 and 10 from the list B straight in. So rather than try to make comparisons for each element, we can put a range in when we're merging. So another example of this, we can see here we've got some numbers. Well, the first list starts off with 1, 2 and 3. Second list starts at 4. So we don't really need to compare these. The first list finishes at 10, but we have 12, 14, 17 in the second list. So we can take the beginning and end out and just merge the middle part. So now we've got 4, 5, 6, 7, 9, 10. Then we can put the whole list in order. So we've got this method, this sorting algorithm, that uses the existing order of numbers to make it more efficient. So far, we've highlighted some of the benefits of using Timsort, but also the Python default sort takes advantage of the speed and quickness advantages of being implemented in C. Now C is a faster language because it's already compiled into machine code, so therefore in Python as an interpreter language, the instructions are executed in order, whereas in C the machine code is already been created, compiled, so therefore it runs quicker. Now we're not going to go into too much detail, but for example, some of the areas where efficiency is better with the default sort, because it uses the implementation in C, would be about the memory and how that's managed, and how the instructions are used with the CPU, so for example parallel processing, and also how you can optimize several areas because you're using the C compiler. So quite advanced, but their point is Timsort's more efficient, but not only we have Timsort, but there are other advantages which use different optimization techniques with the Python default sorting algorithm. Now, that might seem quite complicated, but let's have the best visual example of how to explain the Timsort. This great website shows us visually how the Timsort is adaptive. So here it's finding consecutive numbers, either increasing or decreasing, and then putting them into segments or runs. Now it can change the decreasing numbers into increasing numbers. So then we have sections of the list or runs with consecutive numbers. So now we can see an example here where we've got quite a few consecutive numbers and we want to use that order. So we can see here how the runs are first ordered and then merged together. So smaller runs merged into larger runs, and you can see here we've ended up with two runs, two halves if you like, and then we can merge them to get our ordered list at the end. Let's look at some questions and answers. Why is Timsort fast? Well, we know it's because the insertion sort is good at short lists, small lists, and merge sort is quite good when large lists are used. And also we can use the binary search. So that's why Timsort is fast. What is min run? Well, the size of the runs has to be decided, and this can be used using like a counter and the limit on the size, or the minimum value of the runs is called min run. So that way it can decide, the algorithm can decide how to split the array up. Obviously the more it's balanced the better. So if it's balanced as in equal amounts either side, so 8 on one side, 8 on another, then 8 splits to 4, 2, 1, etc. It's more efficient. So a balanced merge is better when you have numbers of lists with 32 elements, 64 elements, 256 elements, etc. While you see, well, we've already kind of mentioned this, C can be used with more optimized code and it runs quicker because it's already compiled into machine code. Now there are other tricks that Timsort uses to make it faster. We can't go into all of them, but some examples are the data structures, so the way it uses the stack and also the buffer. Another example is Timsort is said to be adaptive. It means that it's different depending on the data. An example of this is that if you have different data types, it can recognize those data types and then change how the comparison operations are used. So different operations will be more efficient on different data. So for example, if you have a list of all integers, all floats, or all characters, you can use slightly different comparison operations to make it more efficient. So Timsort recognizes what characters are used, and then it can use the most optimized approach to ordering those characters. Can we put this into simple words? Well, we haven't. We've got a quote here of some bullet points on how a Timsort works. So this is a simplified version, if you like. And here's where we got some information from. Okay, if you've got any information from that video, or if you indeed liked it, please click that like. And if you haven't already, please subscribe.